All right, whenever you're working with algebra, you probably will see problems that look a lot like this. Simple problem, c plus 9 equals 12. And it's something that you could definitely do in your head and something that you definitely knew how to do back in the elementary school. What's different about now in middle school is you're going to be getting algebraic problems that are more complex, and you have to show your work. So the first thing you want to do in algebra is you always want to remember that whatever operation they give you, you want to do the opposite, and that's called inverse operation. So if you see an addition sign, you are going to subtract. If you see a multiplication sign, you are going to divide. If you see a subtraction, a minus sign, you're going to add. And if you see a division sign, you're going to multiply. These are all inverse operations of each other. They're opposite of each other. Okay, that's the first thing you want to think of when you're working with algebra. The next thing you want to see is if there is a variable. And a variable is just a letter in math. And we do have a variable here, and that is the letter C. And this letter C could stand for any range of whole numbers in this problem. And we have to figure out what C equals. So when you see that there's a variable, the goal is to always get the variable by itself on one half of the equation. You know this is an equation because we have an equal sign, and we want to get this letter C here all by itself. So what we're going to do is we're going to look at c plus 9 equals 12. And if I have a positive 9 on this side of the equation next to my c, a positive 9 right here, I know that I'm not going to add 9. I'm going to subtract 9 because it's the inverse operation. And I'm going to just subtract 9 on this side. I'm going to drop my equal sign, and then I'm going to drop my 12. Well, if I subtracted 9 on the left side, I have to do the exact same thing to the right side because it's an inverse operation, and we want to make sure that we're keeping our equation balanced. So I will put a minus 9 on this side. Then I look back on the left side of my equation. I see I have a positive 9 and a negative 9. Both of those are going to cancel each other out because both of those equal 0, so we could get rid of those. Then what I'm left with is a c on this side, and that was my original goal, to get my variable by itself. So I can bring the c down. I can drop my equal sign in my equation, and I know that 12 minus 9 equals 3. Now, I just said that from the start of my equation up here, all the way down to the c, I am saying that c equals 3. Well, one thing that you always have to do with algebra is you have to double check to make sure that your answer makes sense. So if I say that c equals 3, I'm going to go back up to my original problem. C plus 9 equals 12, and I'm going to plug in that 3 for c. And if I do so, 3 plus 9 definitely equals 12. All right, so that's an example of an inverse operation with an addition problem. Sometimes you'll also get subtraction problems, and what you want to do with subtraction is just the exact opposite. You want to add. So I'm looking for my variable, and I do have one, and it's an n. In this problem or equation says n minus 19 equals 72. Well, if I have a minus 19 on one side next to my variable, I know that I want to add 19. I also want to drop my equation, or my equal sign, and I want to drop my 72. My 72 is there on the right side. I have to keep it. Well, if I added 19 on the left side, I have to add 19 on the right side. I go back to my left side. I know that a negative 19, minus 19, and a positive 19 cancel each other out because they equal 0. I'm left with an n on this side, my variable, and that's what I wanted. I have an n. I drop it down on the left side. I drop my equation. And then I know that 72 and 19 I can add together for a sum of 91. Alright, this is the basics to the beginning of algebra, and this is only with addition and subtraction.